Welcome to AI Frontiers, where the latest advances in computational linguistics and trustworthy artificial intelligence are explored. In this episode, highlights from 36 recent papers submitted to the arXiv preprint server in September 2025 are examined. The focus centers on language models, trust, and transparency in AI, with particular attention to the proof-carrying numbers protocol by Solitario and colleagues. Join this journey through breakthroughs shaping language technology, serving as your guide to the next era of computational linguistics. Imagine a world where large language models justify every number they generate, providing step-by-step explanations similar to how students show their work in mathematics. Current models are now capable of handing over proof for each answer, not just presenting results. This leap in transparency prompts a crucial question. Will such verifiable outputs increase trust in AI systems? In today's episode, the methods by which researchers are turning this vision into reality are revealed. Language models form the backbone of today's chatbots, translators, and numerous AI-driven applications. In domains where stakes are high, trust and accuracy are essential. The September 2025 research collection directly addresses the urgent need for transparency and inclusivity within these systems. This discussion unpacks the motivations, challenges, and key narratives behind these studies, illustrating how present research is actively shaping the future of AI-driven language technology. Computational linguistics functions as the engine room of artificial intelligence, responsible for teaching computers to understand and use human language. This field intersects with linguistics, computer science, and cognitive science, operating much like an engine that transforms raw data into meaning and conversation. Its applications span translation, speech recognition, summarization, and beyond, continuously evolving with innovations such as large language models. A major theme in recent research is the specialization of large language models. Traditionally, LLMs have been likened to Swiss Army knives, versatile and general purpose. However, the current trend involves fine-tuning these models for specific domains such as energy, medicine, and law. For instance, EnergyGPT, presented by Joe and colleagues, is tailored to answer complex questions within the energy sector. Similarly, Rossi et al. Demonstrate that medical LLMs outperform others on Italian medical examinations. This transition from general tools to domain-specific scalpels enhances accuracy, relevance, and trust. Ensuring the trustworthiness and safety of language models is a central concern. Hallucination, in which AI generates plausible but incorrect information, remains a significant risk. The proof-carrying numbers protocol, introduced by Solitario and collaborators, embeds a fact-checking mechanism within the system to verify each numeric claim. Kim and team's HAVE protocol further strengthens neural networks for reliability. The underlying analogy is that of a storyteller who substantiates every narrative with sources. Verified and fact-checked claims are critical for deploying AI in sensitive fields such as healthcare and finance. Comprehensive evaluation frameworks are essential for progress in AI. The NL Superb 2.0 challenge, led by Lee and colleagues, tests speech recognition systems across over 200 languages and dialects, emphasizing inclusivity. DischargeSim, created by Patel et al., simulates doctor-patient interactions to evaluate the clarity and empathy of AI communication. These benchmarks are analogous to marathon training, ensuring that AI models are prepared for real-world complexities rather than just isolated tasks. Such evaluations reveal both strengths and existing gaps, driving the development of trustworthy, globally applicable AI. Several key breakthroughs emerge from the latest research on computational linguistics. The proof-carrying numbers protocol by Solitario and colleagues mandates that every AI-generated number is accompanied by a proof. The NL Superb 2.0 benchmark boosts inclusivity for underrepresented languages, Diffusion language models, introduced by Chen et al., offer creative and robust new architectures. Wang and collaborators present compact, an intelligent pruning approach that enhances model efficiency without sacrificing performance. Notably, the DischargeSim benchmark reveals that larger models do not always outperform smaller ones in effective communication, underscoring the importance of thoughtful system design. A central question addressed by Solitario and colleagues is whether the numbers generated by large language models can be trusted, particularly in high-stakes environments. Hallucinated or inaccurate numbers can lead to significant real-world consequences, especially in fields such as finance, medicine, and scientific research. The proof-carrying numbers protocol is motivated by principles of formal verification, requiring AI models to show their work. For every numeric output, the overarching goal is to ensure that AI-generated numbers are trustworthy by design, mitigating risks in critical applications. The proof-carrying numbers protocol operates at the presentation layer, intervening after the language model has generated its output. Each numeric value is treated as a claim-bound token, which must be accompanied by a proof or documented source. An independent, lightweight verifier checks each claim against a predefined policy, such as exact matching, rounding, or tolerance bands. Only numbers that are successfully verified are marked as trusted, while others are flagged for caution. This fail-closed approach ensures that errors cannot pass through undetected, establishing a robust separation between generation and verification. The impact of the proof-carrying numbers protocol is far-reaching, facilitating trusted AI for high-stakes decision-making in fields such as finance, healthcare, journalism, and science. Notably, the protocol requires no retraining of the underlying models and can be easily integrated into existing workflows. Cryptographic extensions are possible, offering additional security for sensitive applications. Verification policies can be tailored to the needs of specific domains, whether requiring exact matches, rounded figures, or values within specified bands. This protocol sets a new standard for transparency and reliability in language model outputs. Looking to the future, the vision for AI is one of inclusivity and transparency, akin to a garden where every plant thrives under the right conditions. Researchers are working towards AI systems that support every language and community, driven in part by the separation of generation and verification, exemplified by protocols like proof-carrying numbers. Innovations such as diffusion models and trajectory-aware training are accelerating architectural progress. Inclusive benchmarks are empowering global advancements, though challenges remain in bridging resource gaps, improving efficiency, and enhancing explainability. In summary, breakthroughs in trust, inclusivity, and efficiency are reshaping large language models. The standards set by Solitario and colleagues for trustworthy AI are advancing the field, transforming research into a global conversation where every individual's curiosity and engagement matter. Listeners are encouraged to explore the referenced papers, share insights, and participate in the active community shaping the future of computational linguistics. The ongoing narrative of this field continues to evolve, and all are invited to contribute. The synthesis presented here was generated using a combination of AI tools, including GPT 4.1 from OpenAI for summarization, OpenAI's text-to-speech systems, and image tools from Google. Content accuracy and clarity were reviewed by human experts with all references provided, although minor oversights are possible. These AI tools facilitate rapid and comprehensive synthesis of cutting-edge research, reinforcing the commitment to transparency and responsible reporting. Subscribe to AI Frontiers for more in-depth explorations of artificial intelligence and language technology. Follow the channel for updates on breakthroughs, emerging trends, and expert analysis. Your questions and ideas are valued contributions that help shape future episodes. thank you for joining the exploration of AI frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.